Hey everybody, good morning. Welcome to Tech Talk Education. It's Friday, November 1st. I'm Dr. Heldman, and today I want to do a little bit more with PowerShell. I want to talk about a little tiny bit about the nuts and bolts of object-oriented coding, OO coding, because it pertains to PowerShell, and show you a little bit about how PowerShell deals with objects. So it should be interesting. Let's get started and see what's up here. In front of you, you see that I've got some code written here. This code happens to be Java code. It doesn't have to be C#, C, C++, JavaScript, Python. All the languages all know about this object-oriented coding stuff. Python's a little bit differently, but you invoke the basic ideas the same way. In this case, we're looking at Java code. So this is Java. I'll put a little comment here so you know that it's Java. This is Java code, okay? Now I have a class here that I'm declaring. This class is called vehicle. Please take note that vehicle is proper case. That is, it has a capital V. It's not a hard and fast rule, but you really should stick with the idea of making these classes proper case. And even in Python, you'll make a class name proper case. Then what you have is you have a variable here called the speed. And so we know that any object that we instantiate out of this vehicle class, we are going to get an attribute, a property called speed. Now I want to show you that he calls this is called a data field. It can also be called an attribute, or it can be called a property, or it can be called a data field. All of these terms apply, and in the Microsoft world, they call it a property. But the idea is it's a variable inside a class that holds some information about the object, and these are called properties. So this is the object's properties, and it only has one property in this case, and it is speed. And the speed is of an integer data type. Python, you don't have to worry about the data types at all. You won't supply the data type. It's a loosely typed system. Java is very tight about the data types, as is C, and so you'll have to supply that data type, and you cannot get around it. So if you wanted to invoke a speed of, say, 65.5, it's going to truncate that. So you need to be aware that this data type is very specific when you're declaring these class properties. So this is a property. It can also be called an attribute, a property, or a data field. You'll see all of those terms pertaining to this particular property. Okay, now we have a constructor. This is not the case in Python. Python does it a little tiny bit differently. But generally speaking, the constructor has the same name as the class. So if I've got proper case vehicle class, proper case vehicle constructor, and then the constructor has beginning and ending parentheses, and inside the parentheses is one or more arguments. These are called arguments. If you have more than one, you could put in, say, argx and argy, and you just separate them by a comma. But the main idea here is that if I'm going to invoke a constructor, I'm going to invoke it with these particular parameters, and those fields need to exist. So I only have speed here, so I can't invoke argx and argy. It's not going to let me do that. Now the opposite is true. I could have another property up here, and I may not pass in that information to set that property, but there is a way that you can default things so that even when you're invoking the class constructor, you will be able to get a data field that is set. But that data field has to exist inside the class. So all I'm saying is that if you have a desire to create an object and you don't want to pass in certain data, you can have it default to just a default piece of data, and then you can override it as needed in your code. Now, this is not attributes or properties or data fields. This is called the class constructor. So this is the class constructor, and you can recognize it immediately. It picks up the same name as the class, and then it might have one or more parameters or arguments, and then there are always parentheses following this. How does this work? Well, let me write some code here. So I'm going to go down to the bottom of the screen here, and I'm going to say that I'm going to have my vehicle is going to be equal to, and then I'm going to use the keyword new. So I'll say new, and I'm going to invoke the class constructor vehicle like that, but that won't work for me because the class constructor requires that I pass in a speed. So down here inside parentheses, I'm going to tell it that my speed is 55 miles an hour. So what will happen is this is probably going to be in a completely different file. This vehicle class is going to be stored in a file by itself. It's not super necessary, but that's typically the way that it works. And then when you invoke it, you have a different file, and you link the two together. So you link your code together with your classes. There's a way that you do that in all of the languages. And then you say, okay, I'm going to invoke a new object. I'm going to instantiate a new vehicle object called myVehicle. And you use the keyword new. Python does not use the keyword new. And then you give it the constructor name. Python does constructors a little bit differently, but in every other language, it's named the same as the class. And then you pass in any parameters that you need to invoke or instantiate this particular object. So we're creating objects, we're instantiating objects by reading the class instructions here. And then what we do, I take this 55, I bring it right into here. It says, okay, I've got 55. Now I'm going to say this speed equals 55. What does this mean? Well, now this is an odd word, and you don't find it in Python, but in the other languages it is there. And this means this particular object that I'm working on right now. That's the way that I have found the most comfort in working with it. I'm saying, what object? This object. What is this object? My vehicle. So what it's doing is it's saying, okay, the object that you currently want me working on, I want you to set this object speed to 55. What object speed? Well, my vehicle's object. All right, now that is a constructor. These are what are called class methods. And that's the generally accepted term. You might hear them called functions. I slip up sometimes and call them a function because I'm so used to dealing with C++ and C. They use functions. But in this case, they're called methods. And a method is just a little bitty tiny piece of code that does some work on your behalf for every object that has been invoked out of the class. So, think about your average FPS game. You've got a bunch of soldiers on the ground, and you've got enemies on the ground, and every one of these objects was instantiating using this technology, and then they were given certain properties, and they all inherit certain methods. So in this case, there's two methods. There's one called setSpeed, and it requires an argument of a speed be passed into it. It's not going to return any data to me. It doesn't need to, because all we want to do is change the speed of the vehicle. I could put in a comment here and put in comment change speed of vehicle, and then it says this speed equals speed. So it's exactly like this line, but in this case what we're doing is we are calling what's called the setSpeed method and changing our speed from 55 to something. So let's do that. So I'm going to come down here and I'm going to say my vehicle, and then I'm going to say refer to it. I'm going to do dot notation and say dot set speed to 65. Now what that means is that I instantiated my vehicle. It's an object out there. It has properties. It has a speed. Speed is its only property right now. And it inherited two methods. And so we've constructed the vehicle. And now one of the methods that it's inherited is called setSpeed. So I can invoke that using dot notation. So I can say dot this particular object dot setSpeed to 65. It takes the 65, comes into the class here, finds this method setSpeed, brings in 65, and adjusts the speed of the vehicle to 65. This is called a setter. So generally speaking, in object-oriented programming, if the coder is really good, what's going to happen is you're going to immediately be able to tell when I'm setting things and when I'm getting things. They're called setters and getters. Python, not so much, but yeah, they use the same sort of idea. The idea is you've got a verb here. I'm going to set something. Oh, in this case, I want to set the speed of the vehicle, or I want to get something. I want to get the speed of the vehicle. So they're called getters and setters. So let's invoke this getter. So I'm going to say my vehicle dot, and in this case, I want to get speed. Now, I don't need to pass in any arguments. Thus, there's nothing inside the parentheses here. I don't need to pass in any arguments. All I want it to do is give me back the speed of the vehicle. So it comes in here, it finds get speed, and it says, oh, I'm supposed to return something. I'm supposed to return the speed. Well, my speed is currently 65, so what it does is it grabs that number out of the memory variable, returns it to the calling program in the form of an integer. This is called the return data type. So with this method, the return data type is nothing. It's void, which is as it should be. In this case, the return data type is an int. Why? Because I'm asking it to tell me what speed the vehicle has. So this is real basic, but you get the idea here. We're talking about classes, properties, methods, and inheritance. And the idea here is that we're encapsulating data inside these different objects. These different objects are getting their data from this class by invoking class constructors and methods and objects and setting properties. Now let's look and see what a basic diagram would look like for this. Okay, now I brought up Snagit here. I love Snagit. TechSmith is the company that makes this. And you can see here that I've got what's called a UML diagram. UML is Unified Modeling Language. And the idea is that they wanted to have a way where designers could take cards or software and describe all of the different classes somehow in such a way that the programmer would know how to create these classes inside code. So this is a visual look, if you will, of what a class should look like. So in this, we're using UML, and there is some UML software called Star. It's called Star UML, and you might be interested in that if you wanted to get into UML. And if you're interested in a class on UML, Udemy has tons and tons and tons of low-cost courses for stuff like this, so that's a good way to go. So I've got a UML diagram here, and it's saying that I've got a class called vehicle. We're looking at the one property that we have is called speed, and the speed gets an integer. Now it's marked with this minus sign, and that means that it's private. And what the whole idea here is that it is the class that contains this variable. So when I instantiate something like a vehicle, I create a brand new vehicle, I get a private data type there that I can use called speed. It's private, it's in the class, but it belongs to me once I've instantiated the object. In other words, I can't create another variable called speed. It belongs to me by virtue of me instantiating that object. That's part of the baggage that it gets, along with these methods here, the vehicle, the set speed, and the get speed, and there's a plus sign here meaning that these are public. So just like we looked at in our Notepad document here, we've got set and get here. Those are public. So that's what we're talking about there. And so when we have this UML diagram, we see that speed is held, it's private, and it gets an integer. These are public methods. Vehicle is a constructor, set speed, and get speed. And so this is UML. Now let's look at what this looks like when we're inside PowerShell. All right, let's start out with a real blank little variable like, and I'm in as administrator here, and I don't think that it matters a whole lot if you need to be administrator or not. In this case, I'm going to set a variable called eye color, and my eye color is green. I have green eyes. And if I output this eye color, it's going to tell me that it contains green. Let's stop and talk about this real quickly. Now, green is a string. So it's a bunch of letters, characters, spaces, special characters that have been put together into a sentence or at least a word. And green is an object. You need to be aware that in all the languages, a string is an object. It is not a primitive data type. Primitive data types are things like integer, double, float, Boolean. Those are primitive. They're known to all the systems. But a string is a different thing because what it is it's an array of characters that were put together, and we need to have more of an ability to get in there and edit or modify or shape these characters that are inside this string. So just be aware right now that string is an object, and you have to, in a lot of cases, invoke the string library, although that's gotten a lot better in recent years. Okay, but anyway, we've got this color green sitting here. Now the object has properties, so let's tell it that we want to select an object. This is PowerShell now, and we want to give it an input object. This is very common where one of the arguments that you have to give to something that you're invoking will be where my input object is at. What do you want me to look at? So in this case, our input object is going to be iColor. And what we want it to do is to show us all of the properties of the object. So to say all, we do star. Let's see if we can read this. Star, by the way, is an uppercase 8. This is a verb and an object, so we're saying select some object. What object do you want me to select? I want you to select input object. And the input object's name is called iColor. That's what we're going to input to the select object. It's a method. And then we want you to tell us all of the iColor's properties. So the star means all. So we hit enter, and it only has one. It's got a property called length, and it's worth 5 characters. It's 5 characters long. Now we don't need to go to all of this effort. We can just say iColor.length. We can use, in fact, I'll put a capital L. It doesn't care about, it's not case sensitive, but in this case I try to stick with it just because that's how PowerShell is going to output it, so as not to confuse you. And so I'm going to say iColor.length, and it's going to output 5. So what it's doing is it's going into iColor, it's looking at the property called length, finding out how long it is, and returning that back to me. So all this is, length is a property. Notice here that Microsoft calls it a property, not an attribute and not a data field, but the terms they're equivalent. So you're going to read in one book somebody's talking about attributes or data fields, and in another book somebody's talking about properties. And as a matter of fact, if you're working in something like Visual Studio, you're going to see that you've got a properties screen where you can adjust all the properties of whatever object it is that you're creating and working on. So that's the idea here. We've got the length property. Now, a term I haven't given you yet is this. When you're looking at the UML here, these are called members. So we've got member functions right here, member methods. These are members. They're members of the class. These are things that do something on behalf of the class. So let's go and let's see if iColor has any members associated with it. So the command is get member. Now you remember that before, when we were looking for, we wanted to have it get the iColor, we just said iColor.length, and it brought back the length property for us. Now in this case, we're talking about the members, and again, we're going to give it the input object of iColor. And you get a bunch of stuff. Holy cow, look at all this stuff. These are all the members that came along, or that iColor inherited it when we established it, when we instantiated it. So when we said $iColor equals tick green tick, what it did was it instantiated that iColor object, put it in memory, so it's in the computer's memory. When the computer gets shut down, it goes away unless I store it somewhere. And then it gets this property. Where's the property at? It's right down at the bottom here. It's called length. That's the only property that it has. And if we say it's got a get method associated with it, and we use that get method, when we did this. iColor.length, tell us what length you are. But now, notice here, by the way, it's a string, so it's coming out of the string class. It's a string object, and it's got all of these methods associated with it. Suppose, for example, that we wanted to invoke, let me see, the replace method. Maybe we want to go from green to preen. I have green eye colors now, but I want to have preen eye colors. How do we do that? Well, first of all, I'll go ahead and clear the screen. Now, suppose that I want to know what the replace method consists of. And so I say get member. This is a verb, this is a noun, so I'm going to get something out of a member function. I want to get it out of the input object called iColor, the name of which, and this is the member name, the member function name is replace, or member method. So comes back, tells me what the method is. I have a couple of them sitting out here. And in this first case, I'm going to replace an old character with a new character, or I could replace an old string with a new string. So I can do a character or a string. Now in this case, let's go ahead and just change from green to preen. So here's what I do. I say that I want to invoke iColor, and I say iColor dot replace tick P, G, which is green, comma space, tick P, like that. And what it will do is it will invoke the replace method. Why? Because it inherited that when I created the iColor object, and it's going to take and find my green eye color and replace it with a P. I hit enter, and there it is. There's preen. Okay, now you could replace the entire thing. Suppose that I wanted to have blue eyes instead. So I'm going to replace the string preen now. I've got it replaced to preen right now with blue. Let's see if it'll do that for me, and hit enter. And it gives me green. Let's try that again. Suppose that I do green and I want to replace it with blue. There we go. We got that done. Okay, so that is how we invoke that. Now let me clear the screen. Let's do another function. So I'm going to hit the up arrow, get my stuff back here, and I want to look at the remove function. What does it require? Now remove requires something called an index. And the idea behind here is if I have the iColor green, for example, the indexes start at, let me put this on the screen, and I'll also put text up on the screen for you so you can see it as well. Here's green, and I've got 1, 2, 3, 4, 5 characters. However, these characters are known to the computer by their address or their index, and there's an index number for each separate letter in the string, starting with 0. So green is at G is at index 0, R is at index 1, E index 2, E index 3, and E index 4. Get all confused saying E's all that times. So it's a length of 5, but it goes from 0 to 4. So we have to keep that in mind when we're invoking the remove function. So I'm going to go ahead and say iColor dot remove. I'll keep that capitalized just to make sure. And I want to go ahead and I want to have it take out the G there. So I'm going to remove, the R. I'm going to have it remove it at index 1 for a length of 1. And I hit enter. And it pulls out green. Why did it do that? Well, it went into green to index 1, which is, this is 0, this is 1. Found the R and removed it for a length of 1. What happens if I say, well, remove it from 0? For example, let's move it from 2 for a length of 2. What do we get out of it this way now? I want to put a space in there. And it's green, so it removes the double E's out of there. Well, so that's pretty cool. That's how that works. Now, that's temporary. It's only done it temporarily. We haven't written it to anything. So what we could do is we could say new iColor is going to be equal to dot iColor. I got to get this thing out of the way. I've got a thing up here that shows me my progress on the movie. iColor.remove 2 and 2. Like that. And then if I output new iColor, shows me that I now have green GRN. Okay, so that is, in a nutshell, object-oriented coding. The ideas are classes, instantiating objects, properties, member methods or member functions, and then the idea that when you're working with PowerShell, these objects, because PowerShell is an object-oriented technology, these objects have properties and methods that you can retrieve for a given object. Hope you enjoyed this movie. I hope this is helpful to you. Please like for me if you would. Subscribe, please. Tell your friends about it. I'm trying to grow the channel. And you're welcome to leave comments. Several of you have left comments to me. I really appreciate it. And I'll talk to you later. Have a great day. See you later. Bye-bye.